So, this is officially the last week of classes, and since the exam is going to be next week, there's not going to be any new information. You won't be learning anything new, so that we have time to go over everything we've already covered, and you have time to study for your test. There will also not be any new assignments given to you this week. There is currently a homework and quiz due tonight, and potentially a lab if you missed the in-person lab last week. Those are due tonight, and I do encourage you to send me any questions you have as you're finishing those. But those will be the last assignments until the exam. There's not going to be anything new given to you this week in terms of actual assignments to hand in. That means there's also not going to be any lab activity this week. You don't have to come in here physically during your lab time, and there won't be an online lab to do either. There's just no assignments. We'll be able to have time to rest and study as possible, because I know you have other classes to worry about too. That said, I will still be in here come lab time for all 3 days, for all 3 lab sections this week, just so that if anyone has questions and you want to have a study session, I will be in here working, helping people with that. No one is required to come. You have no lab this week, you do not have to come at the times, but I will be here helping people if you specifically want that attention. So, last week of class, no lab. We're going to be getting ready for our exams, and our 2 exam time slots, for those who haven't heard yet, are Sunday at 6:30 p.m. and Tuesday at 11:30 a.m. Those are the 2 different times for the 2 different sections of Physics 1000. I believe this class's time will officially be Sunday, but since I'm giving the same exam both times, I don't really care which one you attend. That said, what I'm going to be doing in the next day, what I'm going to send out very short, today, probably today, is an email with a bunch of the exam information already written in it. What to expect, the topic list, study materials, etc. Included in that email is going to be a link to a poll. There'll probably be like to the website straw poll, just so that I can get some feedback from you guys. Each exam time, and we'll put these on the board so that they're visual. Because for each exam time, I will be in this room physically, proctoring the exam in person, for those who do attend in person. But, because some people need to take it online, there will also be an online option. What the poll I'm going to send out is, I need to know how many people plan on logging into either time and which one they prefer. So in the email, there will be a link to the poll, and you, with your name, will fill in which of the 2 dates you prefer and whether or not you prefer to do it at that date and time, online or in person. I need this information now so that I can plan just in terms of the sheer numbers of people involved. If you are coming to the in-person for either one, then you'll come here as normal. I will have a paper copy of the exam for you and a paper copy of the formula sheet for you. Once the exam begins, you have at it, and things proceed from there. If you'll be doing it online, excuse me, I have two ways you can do it online. My preferred way is at some point during this week, if you're going to be doing the exam remotely, because you have to for some reason, I will be preparing envelopes, sealed envelopes, with a copy of the exam and the formula sheet inside. All of the virtual, during both of these times, if you're doing it remotely, you'll open up a Google Meet call. At the start of the exam, you'll have to be logged in, and you will need, if you have the envelope, you will have to physically open it on camera to begin, so that I see you. And then you'll take the exam, and then you will, when you're done, you will reseal it. I know that this option won't be workable for everyone, because there are some people who will be leaving and not coming back around that time. So this is what this is the option for those who want a paper copy, even if you are doing it remotely. So the straw poll will ask you which of these times and modes you would prefer, and if online, do you want the paper copy? So check your email and do please respond quickly so that I have that information. All right? If I don't have that information, it makes my life infinitely harder. Any questions? Yes.
So if we're online and we don't want to do the paper copy, are we still going to be on the Google Meet call?
Yes. We'll still be doing your exam in front of me. I will send you the exam as we begin, and you will send me your answers at the end. Anything else? One additional technicality, these exam slots are scheduled to last 3 hours. I'll still be here after 3 hours of done. Especially for academic accommodations. If you need the time, I'll still be. But that is the official time slot. Be aware of that if your schedule requires you to go take another exam. Now, this is the when of the exam. Please check your email and reply to this specifically very soon. As for the what of the exam, the actual content, to study for your exam, I highly recommend you look back over your previous tests. Because the exam is just a longer test. It's the same content in terms of the formulas you need and the types of questions you're going to be doing, and it will be formatted the same way. The same way that I write the problems, the same way that they're ordered, and the same system where I give you more points than I grade out of. I think the exam I have 220 points and I grade you out of 200. Which would be the same thing as saying there's 110, I grade you out of 100. But there's more points than you absolutely need. Again, it works exactly the same way as a test, it's just longer and contains material for the entire semester. To help you guys study for that, oh, my mouse was turned on. It's not finished yet, but I'm creating a final exam tab on our Brightspace page, like how we've had a tab for every chapter and every test. So you'll be able to come to this tab for very specific things. For one, on the previous tab, test tabs, I would list rules and information about the test. Those will be there, along with a list of topics. So if you click on this tab, it will eventually read the rules and instructions for this particular exam and all the topics from chapters 1 through chapter 10 that we've talked about. That's mostly going to be material from the past 2 tests, with just a tiny little extra bit of the stuff we covered last week. That list will be here and uploaded as files beneath this. So if you click on something else, you can see the files that are uploaded. When you click on this, there will be files such as practice questions for you to work, like with the tests, an answer key for those practice questions, the formula sheet for the exam. I will send out and create paper formula sheets for everybody. You will have access to it during the exam. I'll make sure of that, but there will also be a virtual copy here if you want to look at it, study it, go over it. And also uploaded here, it's not there yet, but I have scanned my answer keys for both of the tests that we've taken, so that you can use these to go back over your tests. I highly recommend that as a form of study, making sure you understand the questions on the previous tests, how to get the correct answers, what might have gone wrong, etc. So those files will be here shortly. Do recommend coming back to these. And what I'd like us to do today is go over these in reverse order. We just took test 2. It's still the freshest one on your minds. I just finished sending out the grades for it this weekend. So eventually today, I want us to transition into looking at this answer key. I recommend you guys pull up your tests as we do so, to go over everything on it, talk about what from it needs to be studied for the exam, important things that were often missed, etc. And then, if we have time, we may begin looking at test 1. We definitely have time. If we don't finish this today, we can definitely finish it on Thursday. And as a reminder, this whole week is dedicated to review. Both of our class days this week we review. The lab times where I will be in here holding study sessions or review. What that means is if you feel you don't need review, you are not obligated to show up physically. If you think you are studying fine on your own, if you think you are prepared for the exam on your own, I'm not going to require you to come here, because that's just people going places physically where they don't need to. So if you, and there's no, I'm not taking attendance, you don't have to email me ahead of time. If you feel prepared, you don't need to physically come in this week. But if you do, 1, it'd be nice to see you guys. I like interacting with you. 2, it'll be good exam prep. And 3, one thing I really like doing during this last week is just open the floor to any kooky off-the-wall science questions that you guys have that no one else might have answered for you. I get a lot of questions about how do Star Wars work? How do in space travel? What is lightsaber? I welcome those types of questions, and especially now at the end. It's obviously been a weird semester for us all, and next semester will probably be the same in terms of like the rules and regulations for keeping everyone healthy. It hasn't been optimal in the sense that I wish we could have been more hands-on with lab. I wish it would have been easier to get to know you guys without having to physically worry about these barriers and impositions. But it has been nice. It's been a good semester, and I'm very glad to have been able to work with you guys, and I'm dedicated to seeing you guys through the semester well. It has been fun, and I'm hoping it will continue to be fun, and thank you. So, in a sec, I can pull up the test 2 key. We can go over that. Before we do, does anyone have any questions about anything at all? Test related or otherwise? Okay. So, do interrupt me at any time with any inquiries that you have at all. And this is the test 2 key. We're starting with test 2 since it's the most recent one. Everyone's grade should be sent to them by now, so you should know how you did. Overall, everyone did very well. Congratulations. Some notes about how I make my keys, because on top of my handwriting being hot garbage, there's also the fact that my notation might be a little weird. When I make my keys, I work the question so that I have the work, I have the answers, but I also then make note of how many points everything is worth so that I can try to be consistent across the board for everything. So On the test 2 key, I tried to put the points in green to make them more visually distinct from my red grading ink. My test 1 key, everything is red. So if color is an issue for you, I apologize. But at least on this key, the green ink and these circled numbers tells you how many points each individual piece is worth. They all add up to the total point value of the question, and if it's next to an underlined answer, it's a point for getting the answer completely right. If it's next to a formula, that's a point for just writing the formula, period. Again, if you write a formula, you get points. And sometimes there's points for something specific written, like in a written answer, or something specific that you did while working. I might note that as words in the sidebar. If at any point something looks very confusing to you, if you can't decipher what something means as you go over these, please let me know. For this particular key, let's just go through these slowly. This is a slightly earlier draft, so some of the point values have been adjusted somewhat, but all the questions are still the same. So, test 2, we began with temperature conversions. This will be on the exam. Overall, everyone did very well on these, so I'm definitely not worried about them. Some things to note, though. Do include your units on every single answer. This is an across-the-board tip. Write down your units, because if your unit is not there, then technically your answer is not correct, because if the answer is 10, 10 what? I could have asked you for distance, and without a unit, it could be 10 gumballs for all I know. I still give you credit for getting the correct numerical answer. It's only a small penalty. But still, write your units. We've lost space probes because someone didn't write their units down. Story time, actually, because I like this tale. There was a Mars lander, I'm pretty sure it was NASA, that was being built, and NASA is based in the United States. We do tend to use imperial units in the US, so feet, miles. But most scientific communities use the metric system. So some people in the building were using meters, and some people were using feet. And there was a particular document involving a system to help the probe land safely, where someone didn't include their units. I think they did it in feet, and the person reading the document doing the programming assumed it was meters. And so in their coding, they were coding for at what point in the descent do we need to deploy our parachute. It's supposed to happen at this height. But because of the numerical glitch, it happened at this height. The chute didn't deploy in time, and the rover crashed into the surface of Mars into a million pieces because their units weren't there. So that's a couple $1 million we'll never get back. Include your units. Again, also include your formulas. Those are very useful. And specifically for temperatures, 2 of the 3 scales use a degree symbol. 1 of them doesn't. Don't write degrees Kelvin. It will make some people very mad. I won't get mad, but I will shake my head slightly. Additionally, on the topic of temperature scales, be aware of what temperature a problem, what scale a problem gives you a temperature in versus what temperature you need to put into a formula. Across the board, which temperature scale is the best for every single formula?
Kelvin.
Kelvin. Kelvin is the most metrically accurate temperature you can plug in any formula. It works for any of our formulas. Celsius is a sometimes scale. Celsius sometimes works. Those times are specifically when the formula has a delta T in it, because the change in temperature for Celsius is the same as the change in temperature for Kelvin. The 2 units are the same size. Celsius is only legal for delta T, not for just T. But when in doubt, Kelvin. Next, laws of thermodynamics. What you should take away from this is A, remember the laws of thermodynamics. Be able to read a statement and go, think for yourself, that's log 1, that's log 2. This is the specific pattern on this specific test. But I also want you to remember the way that this question was asked, because I might also ask about the laws of motion in the same way. List a couple of statements, you have to decide which ones are the 3 laws of motion. So, again, the laws of thermodynamics, and remember this question format. Next, question 3 was about buoyancy and Archimedes' principle. That's the name. For part A, this is the formula you want. I know it's hard to read from the back, but that's a 3. You get 3 whole points just for writing the formula down. You can easily get a 50 on the exam by just writing formulas. Never leave anything blank. This is our formula for buoyant force. Part A is just finding the buoyant force. Some people were using 9.81 on a test. That's fine. That's technically a better number to use. This is just what I use because bad habits get ingrained in my head, and it's a shorter decimal value. If your number is slightly elevated because you use 9.81, fine, that's great. I'm not going to count you off because you have a better answer than what I wrote down. But a couple of issues that did show up with this question are A, density in the formula. Force buoyancy equals density times volume times 9.81. For the density, this is the formula for the buoyant force on an object that is submerged in a fluid. The density you plug in is the density of the fluid, because the fluid is what is exerting the buoyant force. So, this mahogany block is floating in water. You want to plug in the density of water, not the mahogany. Excuse me. Similarly, the volume. Now, the volume you plug in is the volume of the block of mahogany. But the funny thing about that volume is, if the mahogany block has a volume of 2 meters cubed, it's going to displace 2 meters cubed worth of water. So ultimately, the two values, all the values you plug into this formula have to do with the water, the substance actually exerting the buoyant force. Well, remember that when you're doing the formula. One other technicality, the volume listed in this particular question is 2 meters cubed. That's not 2 cubed. That's 2 meters cubed. The cube is on the unit. The number itself is still 2. Then, part B, will the block float? The ultimate answer is yes. This was not an all or nothing question. If you wrote no, you can still get points for your justification. For example, if you said in your justification, a block should only float if the buoyant force is greater than gravity, that's a correct statement. If you got our number wrong because of your work up here, that was not going to penalize your train of thought down here. So you got points for the answer itself, points for your justification. And there's 2 justifications you can use for why something will float. A, the simplest, you compare the densities. Lower density things float in higher density things. The mahogany has a lower density than water, therefore wood floats in water. Mahogany is a type of wood. The other justification is the force of buoyancy needs to be greater than or equal to the force of gravity. So you could find your answer mathematically if you wanted to. Either justification gets you the correct answer. So things to remember for the exam from this question. Remember how to use the buoyant force formula. Remember these 2 justifications for if something will float in something else. Yep, I didn't say it in the question. Mahogany is a type of wood, if that was not known. Next. This question was the hard one, entirely because of Part B. It was one of the highest point value questions on the test. Part B is specifically the hardest question on the exam, on this test. If you lost points here, that's fine, that's normal, that's calculated. This is the 5 bonus points for getting this completely right. So, if If that trips you up, you're fine. You're still good at things. You know how the temperature has been changing like up and down rapidly because this is the south, and the only thing consistent about the weather here is inconsistency? I have pollen allergies, but I also have rapid shifts in barometric pressure allergies. So I'm going through like a triple whammy right now between weird seasonal pollen that we don't usually get, and Saharan dust, and the temperature of the air crushing my face. So I need even more water than normal. Part A. It's also why my voice might sound a little hoarse. I'm only noticing it today. Part A. We're looking at the pressure, a certain depth within a fluid. This is the formula for that. We want pressure, a certain depth, and a fluid of density rho. So we use this formula. This particular part of the question asks about the depth, the pressure at the very bottom of the pipe. That's 30 meters down. You plug in the full 30 meters. Part B is, again, the hard part because it involves Bernoulli's equation, which is definitely the longest and gnarliest equation of the year. Bernoulli's will be on the exam, but again, there's going to be more than 100% points on the exam. You can't get bonus points. This side already has a sample. So, for part B, the point of the Bernoulli's equation, point of this formula up here, is for comparing two different parts of a pressure system, sort of an A and B, a before and after. This particular pipe is filled with water, and we're eventually going to poke a hole in the tank 1 meter up from the very bottom. Now, before we poke that hole, we're sitting in this system and the water is just at rest. There's 29 meters of water above this point, nothing is happening. We eventually jam a hole in there. The water starts blasting out at some unknown velocity due to this pressure pushing water out of the side. And once it's out of the tank, there's no longer any more water above it. So the system has changed. Various things that were present before now are not. So the trick with Bernoulli's is always to try to start canceling things out. Look for what does exist on each side and what doesn't. For this specific case, the external pressure variable, the just big capital P, the only external pressure on the system on either side would be the air pressure. And air is present here, air is present here, air is present around the whole thing. The air is not affecting one side more than the other. It is universally present in this whole system. So we can consider there to not be any external factors on one side that aren't on the other, because we can cancel the two big P's. Next are the V terms, density times velocity squared over 2. On the before side, nothing's moving yet. So there's no velocity contributing to pressure here. That's 0. On the right, things are moving now. We're ejecting at some velocity. So here there is some unknown final velocity. That's what we're ultimately going to solve for. The last pressure term on either side is the height of fluid above you. And I fully admit my key is probably not the best way to represent this next part, because inside of the tank there's 29 meters worth of water above you. The pipe has a full height of 30, but we're 1 meter from the bottom. So that's 29 meters of water above us on the left, no meters of water above us on the right. So what I wrote up here is mathematically accurate, but I think the better physical way of describing it would be to make this 0 and make this 1,000 times 9.8 times 29. What I have up here is mathematically equivalent, but I don't think it best physically represents it. Whether or not you write it like this, or if you write the 29 over here and the 0 here, it's fine either way. Ultimately, you should get a velocity that's about 24 meters per second, which is very fast, which is why you don't want your high-pressure water system springing a leak. That old trope in the movies where like a submarine or a pressure vessel starts bursting and rivets start flying around in the engineering bay because water starts blasting out, that can happen. And a high-speed rivet will hurt, assuming it doesn't pierce through you. This is very fast. So take care in engineering settings. And again, this was the hardest one. If this formula tripped you up here, you are fine. You will be fine. No one's grade is going to be made just by this equation, I think. Everyone's sitting pretty good. It will be present though, so at least recognize the situations where you would need it, and you'll get a decent amount of points just by writing it down. Next, speaking of pressure systems, question 5 had 2 different pressure formulas. We had Pascal's principle and the continuity equation, 2 different sides of a system of pipes where the cross-sectional area from one side to the other changes. When that pipe size changes, the force changes from one side to the other, and the velocity changes from one side to the other. Pretty straightforward use of the formulas. The only trick here is figuring out what force 2 needed to be in part A. In order to lift a car, you need to exert a force equal and opposite to the weight of that car. So what you needed to plug in for force 2 was not 5